Now that we've started to create custom NetConf tasks for Nornir, we can implement the tasks required to actively manage our network devices. Our inventory files haven't changed, but let's quickly check the Jinja2 templates and variables. We won't actually open the files, but you can trust me that these files are identical from the previous edit config demo. Remember, our goal is to recycle as much code as possible. I've added several new Nornir tasks to the nctasks.py module, so let's explore those next. The only new import we have is the fromString function, which converts an XML string into an XML document object. This is required for issuing custom NetConf RPCs, which we'll need to save our iOS XE configuration. I'll jump down to the updates. First, let's create a wrapper for the edit config RPC. It requires a target data store and an XML configuration string, along with optional keyword arguments. All of these tasks are very short and mostly identical. We begin by getting the NetConf connection, or opening a new one if necessary. We end by returning a new result object, which carries the RPC reply object in the result attribute. In between, we just run a different RPC. In this case, let's call the edit config function and pass in our keyword arguments. That's all there is to it. The NetConf commit function is similar. The only difference is that there are no required arguments and that it sends a commit RPC. We'll use this function to save our iOS XR configuration. As I mentioned earlier, we may need to issue a custom RPC from time to time, like when saving iOS XE configurations. This function requires the RPC text to be supplied. We use the dispatch function with the RPC text transformed into an XML document, just like what we saw in earlier clips. I have one quick comment before I close the file. In Nornir 3.0, which hasn't been released yet, many of the built-in tasks, like those relating to NetMiko and Napalm, will be decoupled from the main project. They'll exist in separate GitHub repositories, but their functionality will be the same, so keep your eye out for those updates. At this point, we've created all the NetConf tasks we need. Let's jump into the edit runbook.py script to put the pieces together. An alternative to cramming all your variables into the inventory files is to manually load them. Those variables are stored in the vars directory as we saw earlier. We can load them using the built-in load YAML task. Nornir also has a built-in template file task that allows us to render a Jinja2 template, returning a string in response. This will be our edit config RPC payload encoded as XML. Then we import our 3 new custom tasks to perform various NetConf operations. The manage config function is a custom task that encapsulates the entire process, containing 4 steps. These 4 steps should look familiar, as it's basically the same procedure we did in the non-Nornir script. We load in the variables, render the XML formatted template based on those variables, issue the edit config RPC to update the device configuration, then save our changes for persistence. The first step is simple enough, which defines the variable file to open, then loads it. The files are based on the inventory hostname, which is easy to reference from the task object. The result attribute of the task1 result variable is a Python dictionary containing the structured data. For consistency with our old scripts, we'll store that in a variable named VRFs. Let's also define the template name to make our next task invocation as simple as possible. We call the template file task, passing in our directory name of templates, the template name, and the list of VRFs. This task obviates the need for us to define a Jinja2 environment, file system loader, etc. Once complete, let's store the rendered text into the new VRF config variable. Now, we can use our custom NetConf edit config task. We'll pass in the target data store and default operation, both of which vary between iOS XE and iOS XR. Also, we supply the XML payload we just rendered from the template, which defines the intended VRF definitions for each device. We'll store the resulting RPC reply into a variable named config_resp. This makes it look like our non-Nornir scripts for simplicity. Speaking of simplicity, let's use a basic if statement to perform different config save tasks for each device type. There are more elegant ways to do this, but I don't want to overcomplicate things. If the platform is iOS XR, we issue a simple NETCONF commit RPC with no keyword arguments. For iOS XE devices, we need to issue a custom RPC. We define the save config RPC text, then pass it into the NETCONF custom RPC task we created. If the save operation succeeds, let's print a status message as confirmation. Just like in the other script, we can print any errors that occur for troubleshooting if the edit config RPC fails. To start Nornir, we initialize it, then run the grouped task named manage config. Nothing new there. In the background, one of the junior engineers completely deleted the police VPN from both routers. Let's quickly check those devices. On R1, we can see that the police VPN is gone with only chemical and chemical management VPNs remaining. What about R2? Likewise on R2, only the chemical VPN is present, which is a big problem. Let's go back to the dev box and fix it. We can repair the network using the edit runbook.py script. This output looks correct, as both devices report success. Let's check the routers again. I'll specifically target the police VRF. R1 looks better, as the police VRF is back and the existing VRFs were retained. All of the route targets look correct as well. Now, let's check R2. Again, I'll target the police VRF. R2 also looks better as the police VRF appears correctly configured. Be sure to test these new runbooks in your own lab environment to better understand how they work.